Okay, we are in the bottom problem of slide 10. And we are asked to relate Kp and Kc. We're given a value of Kc at a particular temperature for the reaction, and we need to figure out the value of Kp. Once again, this is the reaction. Nitrogen plus oxygen. That is supposed to be hydrogen, not oxygen. I got ahead of myself here. Okay, so plus 3 hydrogen gives me ammonia gas. Okay, so this is my reaction, and I know I'm given a value for Kc of 3.6 times 10 to the 8th. And I'm also told that the temperature is 298 Kelvin. I'm asked to find Kp. Okay, I have everything I need to find Kp. Here's the formula for Kp. Kp is equal to Kc multiplied by RT raised to the delta N. And we talked about what each of these terms mean. Delta N is the change in the number of moles from products minus reactants. R is the ideal gas constant, and T is the temperature in Kelvin. I have that number. I know what R is, 0.08206. I need to figure out delta N first. How do I do that? Well, I look on my product side. I have 2 moles. So here's my delta N. Is calculated by, if I had another reactant here, I would look at the molar coefficients and I would add those up to figure out the number of moles. If it were another gas, if it isn't a gas, then I can't really use this reaction or this formula. So on the product side, I have 2 moles, only 2 moles. Now I subtract the sum of all the moles on my reactant side. So I look over here, I have 1 mole for nitrogen and I have 3 moles of hydrogen, which make a total of 4 moles on my reactant side. So I put total of 4. My total product side is 2, my total reactant side is 4. Therefore, this delta N will be a -2. Do not be afraid of the negative, okay? That just means it's 1 over RT squared. So I go over here now, and I have Kp is equal to my Kc value, which is 3.6 times 10 to the 8th, multiplied by R is 0.08206 times T, which is 298 Kelvin, raised to the -2. If I do this, this gives me a value of 9.24 times 10 to the -7th. 9.24 times 10 to the -7th. Go ahead and do this on your own to make sure that you get this number. And this is still multiplied by 3.6 times 10 to the 8th. If you do this math, then you get 332.7. Oops. 0.7. That is my value for Kp, and this is how you would calculate it from the reaction. You will be given a temperature. You would know what R is because it's a constant. You would have to figure out the change in the number of moles, and you do that by adding all the moles of your products, the gaseous products on this side, the right-hand side, and then subtracting the total of all the moles from your reactant side. And it's okay if it's negative. You can still do this calculation and you would be fine. Let me know if you have any questions.